Nonetheless, all the other methods are useful, and it's a little bit of the manager's choice to see what tool are going to be used, or maybe the more tool to understand variability better. So basically, productivity maps, as we said, are divide the field in classes from very low to very high productivity. They are derived from the crop history and remote sensing, as we'll see. So images from past dates are used in order to generate the productivity map. And they define homogeneous production areas based on NDVI maps, allowing to make site-specific management decisions. So basically, these are areas with consistent low or high performance, and based on that, we'll try to characterize them, why or what are the limiting factors, why are they producing less or more, and then make management decisions. Now, the basic principle, if you attended the first webinar, it's NDVI and yield correlation. Basically, it has been shown in theory and in practice a high correlation between an index, which is derived from remote sensing, called normalized differential vegetation index, which in this map it's represented from 0 to 1, 0 the red areas with lower crop biomass, and in closer to green it's the areas with higher biomass. And this was taken on December, while the yield monitor was this was harvested on March. So there's a 60-day difference, and we can see visually, and we can do this with just analyzing both with data analysis as well. We can see a close correlation between the two, between the NDVI and the resulting yield monitor. And maybe something happened in some areas where there's some higher differences. So, but there's a high correlation between NDVI and yields. In most of the crops, extensive crops that we use this method for, corn, wheat, canola, and soybean to a certain extent. So all those crops show the same performance. Rice, of course, cotton, so there are a number of crops that have the same behavior. Now, how are these maps generated? Basically, what we do is we download the history of the images of that farm or field, and we can go, in theory, there are images from 4 years back, but we go maybe 8, 6, 7 years back. In this case, for instance, we are using a series from 2004, 2005, and 2006. There's a certain amount of criteria by the operator, because we'll not choose years where there were extreme events, such as a big drought or a very serious flood. We don't use years where there were trials made, where the different management was done within the field. So we try to have more or less homogeneous management and more or less normal years. So using those images, we'll be able to combine them using geostatistical analysis and create a summary of productivity map with areas that have been historically low and areas that have been historically high in yields. Now, we can also quantify those differences, because what we have is a qualitative map. We have within that field, we know that the area in blue had higher yields than the area in green. Now, if we have additional information, such as in these examples, we have on the left the productivity map, on the right the yield map, we can, through data analysis, which is automated through GeoAgro's Farm 360 tool. So we were talking about the differences. We were saying that on one hand, you have the productivity map that gives you qualitative differences between from areas from very high to very low historical yields. And if you have additional data from a yield monitor, you can overlap that data and summarize results to see what were the actual yields, quantify those differences in the high yielding areas, in the here around 3, in the low yielding around 1.5. So this is also a way of using productivity maps and see what the actual values for the difference were. Now, some limitations to keep in mind. First, imagery availability on the right dates can be a limiting factor in certain occasions, maybe in those areas that are very cloudy. What we do is we look into commercial archives as well. Basically, I didn't mention, this was mentioned in the first session, that mainly we use Landsat 8 images, which is a public image bank. And when there are no images available, then we use commercial images such as RapidEye or Deimos or Spot that you maybe have heard of. So imagery availability has to be kept in mind, that you need to have images on the right dates. Productivity can be evaluated within fields. It's not a useful tool to compare productivity between fields, unless, of course, you have a yield map, as I showed, where you can quantify the difference. But the productivity maps alone is an excellent tool for visualizing differences within the fields. And this is especially suited for annual cycle crops such as soybean, maize, sunflower, etc., as I was mentioning. It requires further analysis when applied to fruits, perennial crops, pastures, because it can, for instance, in pastures, if you have actually cows, or if you're going to harvest frequently, then you need to know those dates in order to draw conclusions from the images. But basically, with this type of crop, soybean, maize, sunflower, wheat, canola, etc., sorghum, this is very well suited and is an excellent tool for identifying variability.